Hello! Today, we're going to demonstrate the key features of an Integrated Development Environment, or IDE, that you'll be asked about in the GCSE A-level exams. We'll use Visual Studio Code and a simple Python program to cover everything from writing code to debugging. This is the code editor in Visual Studio Code. It helps us write code. A simple Python program has been typed into this code editor. First, notice the syntax highlighting. Keywords like def and for are in one color. My function name is in another color, and numbers are a different color. This makes the code much easier to read and helps you spot mistakes. Next, as I start typing a command, the IDE suggests options. This is autocomplete. It prevents spelling mistakes and reminds you of available functions, saving a lot of time. When I finish this if statement line with a colon and press enter, the next line is automatically moved inwards. That's auto-indentation. It formats the code correctly, which is crucial in Python. IDEs also provide error diagnostics. If I make a syntax error, like forgetting a colon here, the IDE immediately underlines it in red and shows an error in the Problems panel. This error message list lets me fix syntax errors before I even try to run the program. The goal of this program is to calculate the sum of all even numbers up to 10. The correct answer should be 30. Let's run it in the console to see the result. The program runs, but the output is 1. That's clearly wrong. The program ran without crashing, but it gave the wrong answer. This is a logic error. This is where the IDE's debugging tools are essential to find out why it's failing. Before we debug, it's worth noting that an IDE's power comes from integration. When we run the program in an IDE, the provided runtime environment helps us translate the program and show the output seamlessly. Otherwise, we would have to switch to a terminal, compile the program, and then see the output. To find this logic error, we'll use the debugger. First, I'll set a breakpoint by clicking next to the function call at line 11. A breakpoint tells the debugger to pause the program's execution at this exact spot so we can inspect what's happening. Next, I'll go to the debug panel and add the variables total and number to the variable watch window. This will let us monitor their values as the program runs. When we start debugging, the program stops at our breakpoint, where the function calculateSum is called. We can step into the function and execute it line by line. In the call stack window, we can see the program has called the function calculateSum, and in the variables window, we can see all local and global variables of the function calculateSum. When we step into the for loop the first time, we can see that number is 1. Then the program evaluates the condition if number divided by 2 with floor division is 0. Since 1 divided by 2 with floor division is 0, the condition is true, and it incorrectly adds 1 to our total. Let's step again. Now number is 2. The program checks the condition again. But wait, 2 divided by 2 is 1, not 0, so the condition is false, and it skips adding the number 2, which is an even number we wanted to add. I found the bug. I used /, the floor division operator. To check if a number is even, I needed to check for a remainder of 0, which requires the modulo operator, %. Let's stop the debugger and fix the code. I'll change the // to a %. Now, if we run the program again, we get the correct result, 30. So, to recap, we've seen how an IDE is a powerful tool that helps us write code more efficiently with features like syntax highlighting, autocomplete, and auto-indenting. And more importantly, we saw how it helps us test and debug our programs to find logic errors using essential tools like breakpoints, a variable watch window, and stepping line by line through our code. These features, all integrated into one environment, are what make IDEs indispensable for programmers.